Okay, I think it's not working. It got interrupted once again. Sorry for that. And hopefully it is not going to create any problem more. So we can say that the torque, because of about the front wheel, and we set this NR is equal to 0, and this will be giving us that our L by 2 minus H tangent of theta will be equal to 0, and here H is the height of the, so this is a slope and these two are the tires. Okay, so this is height H and L is our length. Therefore from here we can find out our theta. So we can say our tangent of theta will be equal to H upon L upon 2H. Therefore the tipping angle theta, let us call this a theta tip, will be equal to, this length is given as 0.08 and height is given as 0.02. So this comes as about 2, and 1 second, tangent inverse, which will be equal to tangent inverse of 2. So therefore our theta tip will be approximately equal to 63 degrees. And when it is facing up the hill, this was our downhill facing, and if it is facing uphill, and for uphill facing also the front, this normal will be equal to 0. And so we can say that our NF, which is equal to our mg cos of theta times L by 2 minus H tangent of theta and divided by L, and this will be obviously equal to 0. So in this case also the basic expression is our same, that is our L by 2 minus H tangent of theta is equal to 0. So here also our theta, which is our theta, our tipping angle, will be also our same, that is 63 degree. So it is not going to change. Okay. And now we can find out our minimum coefficient of friction at tipping angle. So we have minimum coefficient of friction at tipping angle, and we know that we have our weight components. One will be the parallel, other will be perpendicular. So we have our weight components, and weight component will be perpendicular, that is our mg cos of theta tipping angle. Other one will be our parallel component, which is our mg sine of theta, the tipping angle. And then we have our normal force. And at tipping angle, we know that our normal force at the lower end will be equal to our mg cos of theta tipping angle, and the normal force at the or let us say in terms of lower and upper, because the phase doesn't matter. Okay, so let me change this. So let me call this as normal lower is equal to mg cos of theta tipping angle, and normal at the upper will be equal to 0. And then we come to the frictional force. And the frictional force, which is our maximum available, is our F max is equal to mu times n lower. So, and our no sliding condition, for no sliding, the required friction that is our Fr is equal to, or let us keep it the F, required friction will be equal to our mg sine of theta tip, because mg sine of theta tip will be acting down the inclined plane. Okay, and upper there is no friction because it is already at the tipping angle, and therefore we can write that our F max should be greater than or equal to our F required, or we can say our mu n lower will be greater than or equal to our mg sine of theta tip, and we can substitute our n lower, and this will be giving us mu mg cos of theta tipping angle is greater than our mg sine of theta tipping angle. And here mg and mg cancels out, so we get that the minimum value of mu is equal to tangent of theta of tipping angle, which is about 2. And this will be true for our reverse side also. Okay, so it is going to same. Okay, so this completes all the question from today. Okay, I'm sorry about once again there is a problem with the timer setting. I have to check it why it gets disconnected, or the internet might be having some issues. So this completes all the questions from today's session. Thank you.